gentlemen, I guess we've reached the expert panel part of the day, which I always find very interesting and a lot of fun. The rough format for the panel is I usually do a short introduction for each of the panelists, so they rather do it for themselves. Then we actually do 2 or 3 themes, which I think are of interest to all the audience. And then we open it up to kind of extended question and answers, obviously, with the experts. But we'll start off with, if each of you could spend 2 or 3 minutes giving a little bit of background about yourself, your involvement with F#, and your key areas of interest in the world of F#. So just 2 or 3 minutes introduction, just so that the audience has a little flavour of your background and what brought you to this point. So Daniel?
Okay, my name is Daniel Egloff. I'm a managing director of Contalia. We're using F# now for about, I would say, 3 years. We got into F# because we had some interest in option pricing to make libraries more reliable, to get them done quicker. At that time, we also started to look seriously at how we could do GPU computing with F# and started, I would say, 2011, end of 2011, with the first prototype of an F# GPU compiler, which we are now continuously extending. Our main application area is still investment banking, but we're heavily moving into asset management, portfolio management, trading strategies, data analysis as well.
Great. I've introduced myself before, but again, I'm Phil. I'm an ex-games developer who's got into enterprise stuff, and the reason I've got into F# is I like to feel productive. I like to be able to get things done that I wouldn't have been able to get done before. And F# seems to have given me that little extra edge, that things that might have taken me a few weeks, I can achieve in a few days, and I like that. I like that so much that I often talk about it, and it's quite hard to stop me talking about it. And that's really why I'm here.
Right, hello, I'm Nicholas. So I was on the trading side before. I was in charge of building up some exotic team at Société Générale, about total 5 to 10 people. And then I moved on some more market side, plain vanilla options. What brought me to F# is that computation and handling information is really core to all those activities in various ways. And F# was, as other intelligent approach, but F# especially was a good mapping over the things that we were dealing with in various circumstances, be it on a team base or on a more data-focused approach. And now I'm using F# for probabilities.
Oh, my name is John Harrop. I'm Managing Director of Flying Frog Consultancy, so I've been programming pretty much since I was born. I do electronics and physics and chemistry and other stuff as well. So my background's scientific computing, I suppose. So I was from the University of Cambridge. And I use F# the same as Phil because it makes programming fun again, which I love. So I use it pretty much across the board. We use it internally in our company for everything from web analytics to transactions to actual bespoke consultancy software contracts that we do with people. That's pretty much me in a nutshell.
Yeah, Luca.
Yep, so I'm Luca Bolognese, used to work for Microsoft, in the SQL Server team for some time, work in the languages team for some other time, responsible for C#, VB.NET, F#, and the suite of languages in Microsoft. I now work for Credit Suisse here in London. And the way I got into F# was we have this team of people kind of managing all those languages, and there was one guy that wrote code different than everyone else. And we all looked at this guy and say, well, we used to call it Luke's, it wasn't me, Luke's crazy code. And so we all noticed that this guy was the most productive of us all. And all we thought, well, why this code is always looks so strange, it doesn't have any mutable variable, it's all, it used to use a lot of point-free style and such. And so we all started to get into functional programming, and pretty much all my team at some point ended up writing functional code. And then F# came into the Visual Studio umbrella, and so we were all excited at that point to to have a real functional language. At the time we were writing C# in such a functional style. And that all got me into functional programming, and I never looked back from that time.
For the first theme of the expert panel, I'd like to focus on functional programming itself and F# specifically. And to me, I guess, functional programming has been around for quite a while. It has a long history. Why is it now on the ascendancy? Why is it becoming important now? What are its attributes? What are its strengths? And specifically, if you could address why it might be rising very well or coming along in finance quite specifically. So there's no particular order here, so everyone wants to kind of take the question first. So why functional language is really on the rise now, generally and specifically in finance?
Shall I go first? I'd say parallelism and concurrency are probably the two big themes that have made functional programming ripen recently, whereas it was just growing for the last few decades.
In our case, it has been the similarity between the code that you write in functional programming and mathematical expressions. So we have a group of quants that are mathematicians, and for them writing functional code is more natural than writing other imperative code or such.
I wonder also how much the fact that finance use computing and they need it, and they've been using it for a long time, so they needed to have a shortcut and things that work today, tomorrow, yesterday. And so basically, as we progress in time, we refine. And actually, as we refine, we go back in time, as you were saying. Functional programming has been there for a long time, and for some reason, so we're rediscovering, and it looks a lot like a free lunch, and that's what's supposed to not exist in finance, but that's what happens to be.
My first usages of F# were working in the machine learning and perception group at Microsoft Research, and F# let us cross the chasm between developers and machine learning experts, so we could all play in the same playground. And it feels a bit like that in finance, so you've got quants and developers, and instead of them having to talk MATLAB and C#, we can all play in the same area, and that seems to be part of it. But I think what's happened over the last 4 or 5 years with F# being in Visual Studio, Scala and Clojure coming along, is that the tooling actually supports you now. And so you've got similar, you're not held back on productivity by your tooling, you've got the language productivity enhancements along with the tooling enhancements.
Well, I see yet another reason. I think composition is important as well. Especially if you look at quant libraries, you see a lot of data pre-processing, assembling components, wiring stuff together. Obviously that can be done with object-oriented technologies very easily as well, but it becomes big, it becomes cumbersome. With F# you have the computation workflows, you have much better patterns to do this composition, you understand it easier, it is more compact, you make less mistakes. And for that, you can build quicker, larger applications based on building blocks, meaning you can reuse all your investment that you have done before and profit from robust component libraries.
Well, it seems to me that F# is making good inroads into the finance and so on, particularly on the front office, where I think people are more adventurous with technology. But banks are usually typically technology conservatives. So what are the challenges to actually get F# and functional languages more widely adopted for more for other kind of infrastructure type projects? Actually, this is kind of getting more widespread adoption, and specifically longer term, what are the challenges of moving more of these systems based on F# to production in banking environments? So again, anyone can pick up the first thread. So what are the challenges? I think, John, you specifically faced some of the challenges of getting these projects implemented.
Yes, so I was technically insurance rather than banking. So maybe
two sides of the same coin.
They are extremely risk averse as well. So
yes, they consider conservative also.
Giving them a compelling demonstration of real benefits that they're going to get from it, really, that turns people's heads. And as long as you can turn people's heads who have the money, that's really what you're after. You need to get to those people and make them make a decision. And at that point, everybody else has to follow. I don't know if that's the same inside a bank. I think Luca's best question.
Yeah, I don't know either. That's it. Well, when I joined Credit Suisse, they already have bet on F#, so I haven't seen the process they went through. And they bet very early when F# was still in beta stage. So they've been.
Have any systems based on F Sharp actually being moved to the Sharp end of production?
What is the sharp end of
I mean, making money and where it's running 24/7 and they can't
all,
afford to pay
all
for
of them?
All of them already.
Yeah, most of the quant library we have analytics is we have about 1,000 more, 1,300 in F-sharp project, of which 1,000 probably compiled. And of those, I'm afraid this is quite a precise number. And, of those, they are all packaged up in something that we call the analytics package, which is a DLL that gets into all the traders' desktop and in most of the IT places where risk systems are and such. So it's pretty much production.
But is interoperability, just to follow up on that, a big issue in the sense that I remember building a lot of quant libraries in my day, and one of my big sales pitches was it worked all the way from Excel through to the back office. It was consistent pricing, consistent analytics. It was, in this case, it was a highly portable C library, 2,300 functions. But it would work in Excel, and so it was consistency throughout. Is that another major important feature of F Sharp and so on? Is being able to deploy it from Excel all the way through the back office?
And no question about it. That is a big thing. Obviously, we are a Windows shop. If we had Linux servers, that would probably be different. But as a Windows shop, that works pretty well for us.
And Nicholas, I guess
Yeah.
your experience in banking, how to get innovative
So-
technologies adopted.
You had an interesting point. Front office can be more risk takers, including about technology, because they're involved in the process because if it works, it's really good for the business. Technology is not just a side thing. It historically has been at the core of organizing the flow to make decisions and has a direct impact on the bottom line. It just so happened that the language that do have nice impact on the bottom line are also the ones that are interesting from a programming perspective. So again, pretty much. But yeah, so the risk taker thing is more pitchable when you're talking to people who are involved in the process of measuring how successful things are.
Any perspective on this?
I have only perspective from the company I've been working with for the last 5 years, but we use F Sharp on the kind of front office side, the screen, along with C Sharp. We also have sort of post-trade work and sort of more back office, also some in F Sharp, some in C Sharp. I think rather than necessarily trying to make everything F Sharp, and Don hinted at this, is to use F Sharp for the parts where you're getting great value. And I think John's also pointing out one of the ways to look at that is, say, is this something that has complexity or performance or a time to market issue, and create a fact, create something, a prototype that actually works and demonstrates that that's a good technology is much better than talking about computation workflows or monads or something like that. Actually show something working at DSL, and then things tend to fall into place when people actually visualize it.
Now, Daniel, I guess as someone who sells into large tier 1 banks, what do you see as the obstacles to adoption of F Sharp and functional techniques and so on?
I think there are three things to say here. First of all, banks heavily invested into large C++ quant libraries in the past 15, 20 years. And there is a huge body of code in banks being in production. It was investigated, it was checked, reviewed, so they don't want to sacrifice that investment in any way. That's the first thing. The second problem is that almost all of the quants are trained in C++, and that might change in future if they learn how much more productive they will be. And I think precisely there is the chance for F Sharp, because it's all about better productivity. If you look at the time length to get a product into production, say if you want to price a new option and introduce it into so that you can later and introduce it into the front office system so that you can book it, a typical time frame for that is a month. if not more, 3 to 6 months until you get it done, until all the processes have been gone through. And with F# you might be able to show people you can shorten that time significantly, say to a week, 2 weeks, whatever, but it will be not just half, it will be much better. And then I think the benefit would be clear.
I can move on to the second theme of the expert panel, which is centered around big data. From my perspective, I'm actually a big data guy in finance. That's why I teach part-time and so on. Big data you might think is overhyped or underhyped, but the reality is it's a major driver in finance, financial technology today, and also in terms of the business itself. So whether it's overhyped or underhyped, I don't quite say, but it's, I think you ignore it it's at your peril, because it is a driver of the technology at the moment. Now, F# and big data don't seem to occur at the moment in the same sentence. Not like Hadoop and big data, not in the same sentence. Now, is that something that potentially should, you can change or should change? What's the story for F# and big data? As I say, big data means something we simply can't ignore. And by big data, I also tag on other ancillary technology like machine learning and stuff like that. So again, anyone can pick up the thread and start.
Should I start? Okay.
Volunteer.
I think it's both underhyped and overhyped.
Someone's hedging their bets, it seems.
The problem is, what is big data? There's a question of, we have a big data problem or a big data problem. It's not the same. So I think if you really have big data, you really want to have a precise model of computation and to be able to really have a precise hold on what's going on. And that's where F# or advanced technique would probably help you. But apart from that, it's really ad hoc. What we see, we have very specialized system. If you look at time series, you have a KDB or very specialized databases. So
that's beginning to change with things like Deagle. I know quite a bit about Python and Pandas.
Right.
I know where's the
Right.
origin and all that. It seems to me that Deagle is very much along the Pandas lines. That made a huge difference in Python to big data and time series and so on. So in some ways, maybe back to Phil's point, some of the tools are becoming a lot better.
Yeah. I think that now it's one of the main targets of F#, I guess, now, is to tackle that thing. People tried in Python. Successfully or not, debatable. They have made great progress.
Luca, what's your
To be
thoughts
honest,
on
I
F# and
don't
big
know.
data?
I don't know very much about big data. I don't work on big data. We don't tell it in the company. So we just be part of it, things that other people say. I prefer not to expose myself to such things.
John, any perspective on F# and
So-
big data, or even just thoughts?
Similar to Lucas, so my main thought is that a lot of people talking about big data, when I try to get them to quantify how big their data is, the answer they come up with is often comparable to the size of the data sets that we were working with on supercomputers when I was doing my PhD in computational chemistry 10 years ago. And I look at big data and I think, well, basically what you've built is a supercomputer. It's about the same size, but it's just unusually slow communication because there's no InfiniBand. Right? So to me, it's the same old, And yes, it's very important. Yes, there are lots of things you can do with it beyond like simulating nuclear weapons over and over again. There are lots of practical applications for it. I can see that. 10 years ago, it's a bit more than 10 years ago, I was fighting to try to run OCaml on a supercomputer at the University of Cambridge, right, to do simulations. Other people were as well. Some of the largest simulations of Feynman diagrams in particle physics and things like that have been written in OCaml and run on supercomputers. And that was a very fierce fight because the people who owned and ran the supercomputers didn't want very, very slow languages like any functional language, but not C++. Or actually not Fortran, I should say. Sorry, C++ was considered slow to them. Fortran has been Fortran. And so we had to really fight to get OCaml on there. And this sounds like exactly the same thing again. So I would say F#'s general purpose. I don't see why it can't do that exact same thing again if that's what people want to do.
Well, I think one has to distinguish. There is big data structured, which is pretty common in finance, so time series. I would say that that's pretty solved and under control because banks are doing quite advanced models based on time series, although it could be better, but they do that for years and they do that for long. It's a different story for big unstructured data, which change a lot, which has all the type diversity, and there I think strong typing, all the type providers, all the meta information, there F-sharp can make a real difference. Because you can really explore the data faster, better, you see what you have, if something changes, you get that right, and there I see big value, but not that much value for structure, because that's pretty much so.
I don't do a lot of machine learning at work. From working at the machine learning lab in Cambridge, F-sharp's a really excellent fit for exploratory analysis over small and large data sets, and with type providers in there as well. It's really, really great for that kind of area, and we're seeing growth in that area from the F-sharp Foundation. We've got our largest group is the machine learning group, and there's a lot of activity going on there. We've got really, probably one of the best tooling stories, being able to access R, MATLAB, Python, but also have first-class typed code ourselves with a rapid REPL is huge. And I'll kind of echo the big data question. What is it? So,
yeah. What is it you can't ignore it?
Yes.
But I'd like to expand on that theme about the type providers, because that's been, to me, one of the nicest features of the language, and it makes the data kind of like, intrinsic to the language and so on. Is that the wedge that might actually get some foothold or have F-sharp in the same sentence as big data? Because essentially, making applications data rich, data integrated, type providers, is that one way in which F-sharp's going to be much more commonly used in the same sentence as big data because of type providers, the intrinsic interweaving of that data with the language, making it so seamless. Whether the story is large or small, but obviously people these days are very interested in large data sets, big data.
I think we're seeing more and more people turning up at big data events, machine learning events, and doing F-sharp. And it is getting out. Anybody who is in that space and has touched type providers are just, wow, I have to have this. It's just so much more productive. So, yeah, I think it's a real game changer. And I think it's just a matter of it filtering down a little more. But there's a lot, there has been a lot of talks. I was at ORE Dev in Sweden where there were 1,200 developers, and there was a major talk there on type providers, and almost half of the .NET track was dedicated to F-sharp as well. So it's really spreading out there, and I think could be hitting something soon.
To me, type providers is such a critical game changer for the language. And as I say, there's a big data guy. I see that as the wedge that might get a real toehold there. One more pass down the panel. Anything specific you want to say about type providers, their importance and their significance to where F-sharp goes next? Not just in, but I'm obviously focused on big data.
Yeah.
Generally.
Look for instance at main data providers: Bloomberg, Reuters, FactSet. I mean, they're providing time series information as well, but they provide also analytics on top of that and other data based on their time series data. And that becomes unstructured, that becomes complex, and everybody who has tried to programmatically access Bloomberg, for instance, knows how complicated that can be. So their type providers can make a big difference also for these vendors to provide their data in a much better way to the end user.
So to expand slightly on that, we had Rob Farber here earlier today saying about Azure becoming like a data mart and stuff like that. If it delivers all those things up by type providers, that's a great way of delivering data and making access to it that much easier. I think John wants to say something.
Yes, I was just going to say, I regard type providers as a kind of gateway drug. So I'd say get everybody on type providers and reel them in, because there's a lot of other goodness there that we want to get hooked on.
Yeah. To me, it's the one wedge that makes a huge impact on big data, and you just can't ignore big data. That's my thing. Anything more specific on that type of providers from the panel exercise? We all agree it's a pretty big deal, though. I know
Also, actually, I just chip in, because we were talking right at the beginning of Hadoop and big data, and F-sharp big data, and actually Matt, who's sitting in front here, has written a type provider for Hadoop.
I'll be talking about that in my presentation.
Excellent.
It's a Hive-based type provider for doing big data, and I do have a definition of big data. That Ruby's.
I actually have two definitions of big data. And I always have a quibble with them, but I won't give them because I don't want to just do it in the panel, but I do a lot of big data, obviously. One from a user perspective, one from the infrastructure perspective. And anyway, I want to move on to the third theme before we open up to general Q&A from the audience, and that's kind of really important because I think many people in the audience here would like to tap into the knowledge and experience that you have. And the third theme is really about analysis and visualization, stuff like that. And I want to prefix it with a little perspective of my own. I guess I'm the moderator shouldn't be talking at all, but hardly, but I'm going to give my perspective anyway. For me, and it goes back to what Nicholas said, the reason why functional languages become important again now, they were important in the 80s. In some ways, many of the things were figured out. But Moore's Law made them irrelevant for like 20 years. We were just waiting for the next thing to compile. Now Moore's Law is coming to an end. People realize that parallelism is really important. Functional languages have a great impedance match with parallelism and massive and multi-core and so on, which imperative languages don't. So to me, the reason why they're becoming important again is because of Moore's Law and parallelism and stuff like that. So the questions in this theme are really on this line. Obviously, functional languages, are doing very well in analysis and visualization. We've seen that already, and also we have intrinsic integration with hardware accelerators like Quantalia and stuff like that. What's the story for F-sharp in terms of parallelism and massively more multi-core architectures? And they're coming thick and fast. New GPUs now have 2,000 plus cores, and it seems to be doubling in 6 or 8 months. What's the story there with F-sharp parallelism and massively multi-core systems and distributed programming network as well? Anyone can pick up this little thread to start. Ben?
It's a great story. F-sharp is just the immutable aspect of it, and async programming and the networks processor and all these things seem to have been built for such scenarios. So it's just a great language for those kind of things.
I think it also depends on the granularity of the parallelism. F-sharp immutable states is really good for a kind of high-level granularity, but as soon as you want to have massive parallelisms, you have to have all the programming models, because you will not find the right order with all the threads. You lose yourself in the main threads you should work with, so there a programming model like CUDA is important. Then again, we program CUDA with our solution very programmatically, so it looks like C code, but the big advantage of using F-sharp in such a context is that you can write DSLs on top of that, but you can provide further abstractions much easier in workflows, which then abstracts all that nitty-gritty details from low-level parallel CUDA programming, and suddenly you are in a world which is then again much more related to what you usually do in multi-core programming, which is much easier to understand. So I think we're not yet at the end with this innovation, the functional programming for parallel programming, and it will become much more in the future.
I think that comes back to the big data thing. Where's the power coming from, really, is about, there's the execution environment, but also the fact that you're raising the abstraction and it allows you to express computation. The expressiveness is the most important to me, and it's what you get from many functional programming approach. But that's really this part, which is essential. And so it applies for big data because you want to, of course, when you want to have good control, you want to start from high level. You want to optimize your algorithms before you dig into the low part. For the low part is very essential, but first start with the algorithm. And so this expressiveness is the big benefit.
John?
So I've had a lot of success using F-sharp to write parallel programs, and I think the main reason is that they tend to be extremely concise. Not necessarily due to their functional nature, so I think parallelism is a bit bipolar in that you have multi-core parallelism. It's all about exploiting cache hierarchies in memory, shared memory. And then you've got your distributed. And the two stories there are really using the task parallel library, which is a really great framework derived from C++, the .NET, that Microsoft put into .NET. That works beautifully. Interestingly, you have to use recursive subdivision to take full advantage of it, which is very interesting. So that's what you do in C# as well. And then on the distributed side, the mailbox processors and distribution, you need serialization as well. But that's dead easy from F#. It's just a few lines of code to do that. And so in both cases, I've had great success doing both parallel and concurrent programming in F#.
We don't do a lot of compute, so really been using F# for concurrency, but it's been great for that.
Even not just from compute, I also think that visualization has a long way to go in finance. And clearly, these massively multi-core architectures should give you a lot more object richness and stuff like that. And I know that your company does a lot of effort on the front end of stuff. So how do you see kind of massively multi-core F# making a difference to visualization, for example, which is not necessarily big compute, but it's a problem which is well served by these architectures and F#.
Well, so the big benefit we have is from the concurrency point of view, we use the actor model that Jan showed, and typically we don't ever lock anything. We have a message passing based system, so it's very easy to reason about it and scale the system out. It also means that we're not slowed by the slowest consumer. Each feature can run at its own pace. And so it just means that we can scale out a very large project with large amounts of concurrency with minimal effort. I'd love to have more parallel problem, but maybe we'll make one.
Any more perspectives on visualization, for example, with F#? As I say, to me in finance, we have, I came from the scientific area. It seems we're only just touching on things we're doing something in science 20 years ago in terms of visualization, 3D models, spinning around, animate them, stuff like that. What do you see F#'s role in functional programming in terms of visualization? And again, we're probably back to big data as well, as a visualization of big data.
So one of my company's products is a visualization library for F#, and the functional nature of it, so you can write, for example, plot, sign, and it'll plot your assignment, and it'll use heuristics to work out what ranges it should use. And if you plot ATAN, it knows that ATAN is a function of two variables, so it'll plot you a contour plot, 2D plot instead. And it's just that simplicity. It's the combination of the fact that it's functional, so you can pass sign in and out of functions and don't have to think about it, and also the fact that it's got static types, which is quite unusual. So you couldn't do that in Python, because Python couldn't use runtime introspection to determine the type of the thing that you passed in. So F# would just accept any value of any type and then use reflection to work out what it actually is, which is very nice. There's a lot that you can infer from the types that the user puts in, and the idea is to use that interactively. And I think we've just scratched the surface, to be honest, of what's possible with that. I think there's far more that could be done.
Any more thoughts from the panel? At this point, I'd like to open up the panel to general questions from the audience. If there's that pet problem you haven't solved yet, you want access to the knowledge of an expert, feel free to ask. Now, you can ask the question directly to a particular member of the panel if you think that they're the best person to ask, or it can be a general question to the whole panel, and anyone from the panel can ask. So I'll ask for and again, do we have anything more goodies to give out if people think good questions?
I think we do have a few more, yeah.
Okay, I'll leave that until we'll try and remember whose hands go up and so on, but we have more goodies to encourage questions. So questions from the audience for the expert panel. So
to look at does you build all your quant library on F#, have you built an automatic differentiation directly into it?
On most of the primitive quant function are in C++. So we have a C++ core. It's actually, we have a C++ core that then gets exposed as common component, gets wrapped into Excel things, and then we have Sharp to tie all those things together. But the differentiation one is, I believe we use the existing one, an external library actually.
So in principle, F# would be pretty good at it. And building it in directly.
next question.
Deep in a bit on your question first. Actually, if you write the library right using more code quotations, it's pretty easy to add automatic differentiation in a very clever way. because it's just yet another transform of your expression, and you don't need all that kind of object-oriented backend, for instance, like double process with special knowledge about the AD methods. It can all be handled through expression transform, which is much more powerful actually than adding it through the object-oriented way.
There is an example in Don's book, isn't there?
That's right. What's Don saying?
Oh, that's it wasn't what I was going to say, because that's the example in the book is a toy example, but what I was going to say is there's a lot of people who want an automatic differentiation library in F#. There have been historically various financial companies have done in-house projects that have done them pretty high quality for adding automatic differentiation. I think it's a great space for the community foundation, companies willing to contribute to the community foundation to look at, beefing up, ticking off that box for functionality available in the F# ecosystem. So great space for cooperation as well in the public.
I guess, to expand on your comments, sort of, I guess it is clear that there's an F# community, and more kind of the financial community contributes, the more you get back as well.
Yeah, I mean that's true from the Microsoft research perspective. Just next week we've got one of the luminaries in automatic differentiation visiting us, because the machine learning people at Microsoft Research, surprise, surprise, want a great automatic differentiation library. So we're in the same position from a research institute point of view as many of the financial institutions are here. So it's a great space for cooperation. I think the whole Microsoft ecosystem has recently become extremely cooperative through NuGet, and 15,000 NuGet packages up there. So it's becoming very normal to take a more cooperative approach to developing these key components that are frankly better when we're all working together.
We'll try and do our best to encourage the folks in finance to come along with that.
Yeah, that varies. Obviously, it's just fantastic to see Blue Mountain as such a big hedge fund taking a real lead and showing that they drive real business value.
They've done an awesome job with Deedle and making it open to the world. And as I say, I think we can see an awful lot more type providers, out there providing for free. Like, I'm sure the data vendors in the finance space, it's in their interest to have type providers, available. So that's another way. Next question, sir.
Well, I'll do two. Can I answer the last question and then ask one of my own?
So you're a pseudo-panelist, okay.
Yeah. So, finance is actually ahead of you on this. Mark Henrod and OpenGamma are writing code, developing software with algorithmic differentiation for swaption valuation. So someone's given them a few $1 million to set up a software firm to use that. So that's one. I thought you were leading the panel about big data, because it's obviously an interest of yours. As a rather naive finance guy, I thought the key topic is high-frequency trading and latency. So that's where I think the serious development from a finance industry hot topic is now.
Okay, I might have some insight about this. Is when you talk about latency, you have to talk about the price of a marginal increase in latency, and it's not a linear function. It's actually, if you have something that runs kind of slowly, if it runs a little bit slower, you don't lose so much. It's been designed for that specific way of operation. On the other hand, if you're talking about ultra high frequency, so you're on the most competing edge, then the value of 1 nanosecond is extremely high. So you have a curve which is like that. It goes down and then you shoot back up. So there's not one general framework about ultra high latency. You have to.
Well,
you have
Nicholas,
two
but I think it's an opportunity, because
absolutely
stock markets are making all their money from letting people buy latency through access, through having your hardware next to each other.
Sure.
It must be better to hire software engineers to write better software, so that the application is code is low latency, and you don't have to pay to the stock exchange quite so much for co-location.
I don't think that this is a good application for F-sharp. Ultra high frequency has completely different dynamics, so you would probably use other technologies, other hardware, other software even. I think, and it's structured, so it's pretty simple. It's just a lot, and it's arriving very fast, so you have to deal with techniques. How do you bring the data very fast into your computer? You have collocation, you have a lot of hardware issues, special drivers, so you're at the other scale where F-sharp is sitting. F-sharp really comes in if you start to try to build models in tradings where you really try to understand the world much better with all the data that you can collect. And there it's rich, it's unstructured, it's complicated, it changes, and there I see some value for F-sharp. But not even
So that's clever data.
That's clever data, yes. And F-sharp is a clever language.
Yeah, but I think one thing you have to understand about high frequency trading is it has two distinct aspects: execution and all the kind of like things that you get after execution, like strategy development, back testing. That's execution is all latency. But there's a huge part of the business which is essentially strategy development, back testing, time series, machine learning, stuff like that. That's an area in which I think F-sharp will do very, very well. But on the execution side, it's going to be C++ probably now and forever, because it's just so close to the metal. So I think there's two aspects of HFT, and one is a bit better match than the other.
I completely disagree. So
That's even better with the panel instructions.
yeah. So I think if you want to go low latency, you don't write software. You don't use C++. You build your own hardware. You make sure it does everything on one side.
Yeah, so FPGA, x86 and so on. Okay. Yeah, but even those are kind of, okay, was it C++ or VHL or some very low close to the metal language?
Yeah, well actually, so, I forget the name of the company, there's a company doing a functional language that compiles to hardware, so that's the kind of thing that I would go for, and obviously a functional language I think would still be a good fit for that now. Maybe it's not going to be F-sharp, I'm not sure what tools there are to compile F-sharp to hardware, but if we've got to compile it to GPU, how hard can it be, to be honest? But definitely I would go for, a custom-made box with purple strip lighting over a pile of C++ code any day, open twice on Sunday. But that's just my
Welcome it is. Interesting you mentioned the Open Gamma folks. Actually, two of the founders, Kurt Wiley and Jim Moores. And Jim Moores actually used to work for me, so it's a small world, surprisingly. Next question. Sir.
I have a question with applicability, because, I'm still struggling a little bit to find the reason to use F-sharp. Maybe there is as a C-sharp programmer, and the C++ programmer of old and Fortran programmer, I fail to see a compelling reason to use F-sharp, because maybe I fail to see a class of problems that it solves much better than object-oriented language. And that would be great to provide you with, some hints as to what sort of problems are lending themselves naturally to F-sharp.
Who wants to take this one?
So, go ahead. Yeah, okay, I'd say math. Oh, go on.
Okay, the one that I see time and time again is analytic components, typically a calculation engine for pricing at the F-sharp user group. That's what we've done, that's what I see happening time and time again. And with the domain modeling, unions, pattern matching, you can really put together a lovely calculation engine that works, that's correct, it's high performance, and then you can tune it with different algorithms, and you can just do that in a matter of days, where with a more a language like C# or C++, once you've gone in one direction, you tend to be stuck in that direction. So it's almost thinking of your code not as a long-term investment, but something that you can actually create an entirely new version of with new algorithms within a matter of days. So it is a different way of thinking. I think it does tend to be on the more complex side of things that you gain the real leverage. For CRUD, there's absolutely no value over PHP, C# or anything else, but for more complex analytic components.
Before John answers, I'm going to ask a question of Luca, in fact. With Luke's crazy code, what problems was he solving that was so productive that really caught your attention?
Yeah, so I wanted to give a more personal kind of answer. And, we can spin all the marketing around F-sharp as much as we want, but personally, having been a kind of a C++ programmer for I'm pretty old, so for a long time in my life, then a C# programmer, when I moved to F#, a couple of things happened to me. One is that suddenly the kind of problems that I was comfortable solving became much more complex. Before, I would see something in front of me and I would say, oh crap, I'm sure I'm going to get that one index wrong, I'm going to get the structure wrong, it's going to take me forever to get this whole thing right. Now I look at the problem, even a complex one, and I say, I can go and do it. So it kind of erases the kind of problem that you are comfortable approaching and solving. And the other thing that happened to me is that there are way less bugs. So the same, for the same problem that before would have scared me and then would have required me a lot of time debugging and finding the problem, now it doesn't scare me anymore. I can do it in a reasonable time, and the final code is less buggy than it would otherwise be. And if you think of this is a very personal kind of thing, but if that's true for more people, that's a huge impact on the industry and on almost all the code that we release.
But that leads to a question why there is so much lag in the adoption of F#, because the first version came in 2007, and we are seeing slow adoption when compared to the C# world.
So you make an assumption of an ideal world in which something that is better immediately replaces something that is worse. Such an assumption is not true.
John, can I repeat you?
So yes, I mean these guys have said a lot. So I think one great example is rewriting trees, right? So anywhere where you're doing term rewriting, you're doing term level evaluation, you're doing computer algebra, you're doing interpreters or compilers or theorem provers or all those kinds of programs where you're rewriting trees. It appears in graphics as well. F# is just hands down winner by over a factor of 10 in code size, right? And you try to write that stuff in an object-oriented style, it's absolutely horrific in comparison. So that's probably the best place that you can look at. So if you face any challenges like that, then definitely try and compare the two on there. As Phil said, in other applications like CRUD, there is literally no difference. So you do have to pick your battles in that sense.
Another question, John?
I'll actually offer a bit of a technical answer to the question from the other side of the room. One of the strengths of Fortran, and I used to be a Fortran programmer, is that the constructs in the language lend themselves very naturally to the compiler doing a lot of optimization on it for you. So you write natural code in the language, and you get the optimizations and the performance for free. One of the places that functional languages are going is the natural expressions in it. You tend to be more concerned with telling the compiler what you want to do, and not so much about how you want to do it. You tend to be operating more on sets instead of elements of sets. All those things make it easier for the compiler to go, hey, this is how I match this problem to the hardware. This is how I optimize it for you. You spend less time trying to figure out the clever way to do something and more time thinking about the problem. And so I think in some sense, functional languages are a little bit like Fortran in that they make the compiler's job easier. Probably the first time anyone's compared F# to Fortran.
Another question from the audience. Sir?
So I have C#, massive C# type hierarchy describing the assets, asset types in our system. And I look at this, I'm a newcomer to F#, I look at it and think this could probably be rewritten far more succinctly, concisely in using F#, things like discriminated unions and the like. Problem is we've got it's a big distributed system. How we're passing these C# objects around using the data contract serializer in C#. How are people passing around objects, F# objects, or should I be approaching the problem?
So we do the same thing, exactly what you're describing. We have a vast library with very different contracts that we pass around to the farm to execute on farms. And we have written our own serialization, not because we couldn't do it in F#, but because we needed a different version, because the code that is on the farm might be the different version they want to stick with. .NET doesn't give you that version in your code. But if you're really passing things around, then you probably have this versioning problem as well, and probably you're writing pretty much your own serialization as well. And so there is a big difference between C# and F# in that scenario.
So, take discriminated unions, for example. Is that supported in data contracts?
I'm sure data contracts.
Yes, you can use the usual .NET serializers with F# types, but I must say methodologically I'm quite in favour of Luca's approach. Just take serialization frameworks tend to be such a source of problems as much as a source of help that just take control of your own destiny and write the 200, 300 lines of F# code that walks the data model, very safe, accurate code, and control your destiny and look after your data format. I mean, you can do both. I'm not saying it's an absolute rule. I'm just saying it's an often applied rule, and more often applied in F# because it's just so easy to write a serializer over the instruction model in F#.
So that's the way.
Yeah.
It's
Just very common. So we do that in the F# compiler itself, for example. We don't rely on .NET structure as serialization to look after your data formats.
I've solved essentially the same problem in the same way, but I would stress that I used values instead of objects, so they had no mutable state in them. I had a lot of problems with the .NET serializers because they require mutation to construct the objects coming in, which is really irritating. But if your code is performance critical or even performance vaguely important, I'd avoid all of the .NET serializer stuff and just write your own serializers because they'll be 10 or 100 times faster.
We're in a fairly similar boat. Performance is just way off for us, so we use a combination of custom serialization. Sometimes we use Google Protocol buffers as well.
Another question? Sir?
Talked a lot. I've used F# before, but the type provider thing is obviously pretty key and quite a powerful looking feature. But it looks a bit like a combination of adding web service references or entity framework or link to SQL, a way of pulling in external data. I just wondered what your perspectives were on how it is different to those technologies, and is it somehow more sort of built into the language, more so than generating classes and using those kind of mechanisms in C# say, for example?
So I'd say that is what the 5 separate steps that you just said you do by hand in C++. That's exactly what type providers are doing under the hood, but it just automates it. That's literally basically all it does. And so therefore you get all of those drop-downs instantaneously, and it's constantly redoing that in the background and updating if the other end updates and so on.
Is there any downsides to it? It's a very nice feature in that respect.
The main downside I've experienced is that it sits on the rest of the Microsoft tool stack, which doesn't necessarily talk perfectly one-on-one with, for example, Java tool stack. So if you try to interrupt with some foreign systems, you can hit bugs, but they're not bugs in the F# stuff. They're bugs in the rest of the web reference tool stack that you get exactly the same if you try and use them from C#. That's the only issue I've come across.
So I'll also point people to NDC Oslo, which is actually coming up in London, and also the recording of my talk from NDC Oslo, where we go into a lot more into depth into type providers and trade-offs. I'd add a couple of comments. One is scalability. Type providers, unlike the mechanisms you're talking about, type providers can scale arbitrarily sized information spaces, and that's just incredible. Right? That you can't code generate an individual type for 20 million entities in a database, but you can do that for using type providers. And it doesn't use code generation. Some of the type providers use actual code generation under the hood. Many of them just erase or use an erasure model, so actually there's no actual types generated. There's no code like whatsoever. There's zero runtime cost for accessing these massive information spaces in a strong runtime way. So those are some extra dimensions to what we're talking about.
Since Lars actually mentioned it, NDC London is coming up the first week of December, and in your information pack is a discount code, I think, for about almost £300, if you're interested. And I think we have Don, you're speaking NDC in the first week, and I think Phil, Thomas, anyone else from the crowd? But I'm just saying it's coming up quite soon, right?
Yeah, there's quite a few.
Sorry?
I'm crowing.
Okay.
Yeah, so advertising mode. NDC coming up in London, and we've got F# in Finance in New York, of course. I mean, some of you work for institutions which have New York offices, and I guess we'd love to see your colleagues at the New York event as well.
Next question, because we have time for a few more questions.
Maybe this is a very generic question.
Okay.
This is from my, what Microsoft should do for more fast adoption of F#.
So more of what they're doing now, which is engaging with the community. It seems to me is one way. This is actually what we're doing now. Also.
So actually, regarding this, I know about 2 institutions who use F# and they don't want to say they're using F#. So
it might be more widespread than people in the
exactly. And I mean, one for a very good reason. They actually think that it's a competitive advantage, and the other one.
I want to get a few more questions in. So, sir.
Johnny spoke earlier about a little trick to write application as code in a Force Crystal Group, and it was spoken about before that under the hood in the intermediate language, some of the simple constructs in F# generate a lot more code than you think they do. Are there any kind of traps that you find? Is there anything that you think looks really cute, but just because the compiler is not designed as because F# came after the compiler, and so you can get yourself into some trouble when you think that you've written quite cute code.
I think, I always think I write cute code. I think I've come across a few places where, I've been very surprised by the performance. It's rarely over an order of magnitude. So one case that jumps out at me was the serializer, actually. So I was writing a serializer, I've got async. Got to have async, got to work over there. I'll do async for every byte that I'm serializing, right? And that got me 250 times slower. So what I did was just did async per message, and then it's no performance overhead whatsoever, so immeasurably small. But it's exactly that kind of thing where there's some language construct, and it's just like magic that happens, that kind of stuff. I don't really know what it was doing under the hood until you whop open the profiler and it shows you what's actually going on, and you go, oh, yeah, no, I don't want to do that per byte. So there are a few things like that. I suppose the other one that comes up quite a bit is things resorting to generic comparison. So if you, for example, if you have, I think, a tuple A, B and compare it with a tuple 1, 2, that's a lot slower than doing A equals 1 and B equals 2. And there are things like that, but you very quickly pick up on these kinds of things. Obviously, I've documented them all extensively as well, so everybody can just read that. In general, I would say, and interestingly, this goes against the comment that was made over there, I really like the fact that F#'s very simple compilation model gives you a really predictable performance profile. So once you've grokked those caveats, you can look at quite a big piece of F# code and you can have a very good idea of exactly how fast it will run, and if you need it to run faster, exactly what you have to do to make it run faster. And that's exactly the same benefit that I found in OCaml. OCaml also has a very simple compilation model. It's really easy to work out what its performance is going to be like. And that's completely the opposite from Haskell, which is one of the reasons why I've stayed away from Haskell. So, does that answer your question?
To give you a slightly different perspective, we have a large F# application that has been built for the past 2.5 years with on average 8 developers working on it for this period of time. And we just went through a process of optimizing the performance and the memory consumption of such application. And first of all, obviously the profiler is your friend, right? I mean, whenever you do some of this stuff, you cannot just start guessing and removing random things from places. So you go, you profile it, and things that we found that are a lot of things we found that was kind of our fault. It's not the language. It's just we have some data structure that weren't as efficient as they could be. In the core loop of our application, we were creating a lot of closures, and those ended up slowing down significantly all the message kind of processing. Other stuff were more generic things, not F# specific, like we were floating the UI thread for notification and things like that we have cured. But that was a little kind of snippet. But I think any language you use, you might end up with that unless you write assembly.
A question from this gentleman?
Yeah, Luca, you talked about Credit Suisse being a Windows shop. To what extent is F# being tied to Windows a barrier to its adoption in finance in particular? And is Mono a viable runtime? Does anyone actually
Yeah. I mean, it's. I think that's perhaps the biggest adoption block for Sharp.
So is Mono viable? Is anyone doing
I
that?
think it might be viable. I think there is a bit of a reputation there, or at least the impression that it's not viable. To be honest, I haven't used it in my own, so I have no personal experience if it's viable or not.
Phil, can you work with Mono?
Oh, well, I've done Mono on the client side. The latest garbage collector, the main issue for Mono has always historically been the garbage collector. The new SGen garbage collector is so much better that we are approaching usable for financial apps. There are some people kind of on the edge of the finance sector doing large applications with Mono. I think the biggest case is Greg Young with his event store, which is running on Mono. And that's a huge high-performance application. So if Greg can do it and be running hundreds of thousands of not transactions, but writes per second and reads per second, then I think we're on the cusp of it. I think the other interesting thing that's happened, so we have Miguel is a real F# fan, and he's also come in with Microsoft recently with a partnership focusing on mobile at the moment, but I can only really see good things coming from that. If the mobile platform starts to get better, which it has been, we can probably reap the rewards of that on the server side too. And potentially, customers who have become interested in the mobile platform will help drive the server side platform. So it's looking good, and I think for sort of in the middle, not high frequency trading, but on the cusp, it's with the SGen GC, I think we're there.
We have time for one more short question. Sir?
Yes, so beyond language features, where's the place to pick up sort of idioms and patterns and, this problem, this is how you solve it?
The F# journal.
It's just rather self-serving comment there. John is the publisher of the F# journal.
Which is great.
Which is a great journal, by the way, because I'm glad you plugged it. It saved me the trouble.
The F# snippets website.
Oh yes, also extremely good.
But in all seriousness, that's one of the resources. But there are a lot of tremendous resources in the space. I'm fairly new to F#, and you just come across all these things, that are available online, the interactive, F# journal, in a browser and so on. It doesn't want for some great resources. Don, could you or Phil, could you summarize it like a sentence or two?
The superb side is F# for Fun and Profit, which you can find many of the resources you'll find off the fsharp.org community website, the F# Software Foundation website, fsharp.org. Some of those will take you either to F# for Fun and Profit, or some will take you to Try F#, and there's snippets and many other, and also all the books that are available on F# coding. But really, the F# for Fun and Profit is just a superb presentation of the role of functional programming from maybe a more general enterprise architecture point of view on the role of F#.
Just to throw in, outside of static resources, the F# community tend to be hugely responsive. And if you were to post something, there's a code review site. So if you're getting started and you want to know if you're idiomatic, you can post up something. People will come in and give you kind feedback and help you. And also on Stack Overflow, literally, I'll put something up there and Thomas will have answered it 5 minutes later. So, because none of us can get to it fast enough. But seriously, it's, as well as the static resources, one of the great ways to really get into a language is to learn from what other people have written and get feedback from other people. I think if you're in an environment working with other F# programs, it's a huge win.
Now, unlike John, Phil was sufficiently tactful not to plug his forthcoming book, so I'll actually plug it for him because I actually have 2 free ebook codes from his publisher, to give away at this conference.
Great.
Now there's a forthcoming book by Phil and Thomas.
And
and it's coming quite soon, right? Or is it out already?
It's coming quite soon for a long time. It's coming soon.
Okay, but I have 2 free electronic codes for the ebook version of it, and I haven't decided how best to hand them out yet, or whether it's for the best question or just a whim on my part. But 2 of you will be the lucky recipients of Phil and Thomas's.
The important thing is that we are not really writing it. We just get all sorts of other people from the F-sharp community who are experts on particular topics writing it. So we don't have to do any work, and there's going to be great content from people who actually use F-sharp, mostly in production, in different domains.
Even better, but I'm just saying the 2 lucky folks from this conference will be the recipients of those codes.
What's the title of the book?
Phil?
F-sharp deep dives.
Deep dive, there you go. And with that, I'd like to say thank you very much to the panel.